Hey pre-calc students, in this video we're going to solve some more trig equations. We're going to focus on trig equations that require the use of factoring or identities. First thing to remember is equations that are polynomials. When trig equations are in the polynomial type, you can solve by factoring and then setting your factors equal to 0. Here's an example of a non-trig equation that's a polynomial. We have 3x cubed plus 5x squared plus 4x equals 0. I can factor this equation. And then once you have it factored, you can set each individual factor equal to 0. So then I have three x values that when I plug them back into the original equation, they'll make it true. Like for instance, if I wanted to plug in -4, when I plugged in -4 in for all of my x's and I simplify, I am left with a true statement. So -4, as well as this would work as if x was 0 or if x was -1. When I plug these values in for x, I'll be left with a true statement. One reason why we're going to need to solve by use of factoring is any times you don't have like terms where you can combine them. For instance, it says solve in terms of radians by factoring. I have sine of x plus sine of x times cosine of x equals 0. Because I have two separate trig expressions, both sine of x and cosine of x in the same problem, the only way I'm going to be able to do this is by factoring. I notice that both of my terms have a sine of x in them, so I'm going to factor out a sine of x. I can check my work in factoring by multiplying back out. Sine of x times 1 gives me sine of x. Sine of x times cosine of x gives me sine of x times cosine of x. So again, you can always check your factoring work by remultiplying. Once you have it in factors, you can set each factor equal to 0 and solve. Okay, sine of x equals 0 at 0, pi, and 2 pi. 1 plus cosine of x equals 0 when cosine of x equals -1, again subtracting 1 from both sides. Cosine of x is going to be -1 at the value pi. Again, I'm doing this in terms of radians. And because pi repeats itself in my solution set, my final answer will only include all solutions once. Okay, the next problem says solve in terms of degrees by factoring. And in order to solve by factoring, you have to have 0 on one side. The reason why we need to have 0 on one side is setting factors equal to 0 is what's called the zero product property. And this only works when factors equal 0. So I'm going to start this problem by combining like terms. I'm going to add 3 tangent of x to both sides. And then that way, all of my like terms are on one side, and I have 0 on one side of my equation. From here, I'm going to solve by factoring. Pause the video and see if you can factor and set your factors equal to 0. Pause your work. Or pause the video and check your work. Tangent equals 0 at 0, 180, and 360. Again, remember, tangent is sine divided by cosine, so I was looking for when that would equal 0. And then sine of x minus 1 equals 0 when sine is 1, and sine is 1 at 90 degrees. So my full solution set is 0, 90 degrees, 180 degrees, and 360 degrees. Another time where you're going to have to solve by factoring is when your equation is set up in a quadratic form. So solve in terms of radians by factoring. 2 times sine squared of x minus sine of x minus 1 equals 0. Anytime you have a square and a regular like a sine squared and a sine, you'll also have to solve this by factoring, because we can't combine sine squared and sine into a single sine term. So the first thing that I'm going to do is, I do see that it is a trinomial, so I'm going to factor this into a binomial, two binomials. I know that if I multiply 2 times sine of x times sine of x, I'll get 2 sine squared of x. And then I know that I need to multiply to get -1. So I'm going to do a -1 and a +1. And I can always check my work to make sure that this would multiply back out to my given expression. So if I was going to really quickly check my work, I can multiply it back out and see that I got the original expression. So this is the correct factorization. Once you have your factors, we're going to set it each factor equal to 0 and solve those two equations. See if you can pause the video and set your factors equal to 0 and solve from here. Okay, when I solved this equation, I wanted when sine of x is equal to -1/2. That happens at 7 pi over 6 and 11 pi over 6. Again, they wanted this in terms of radians. And then for this factor, I needed sine to be 1. And again, that happens at 90 degrees, or in radian form, pi over 2. So my full solution set, writing these in increasing order, pi over 2, 7 pi over 6, and 11 pi over 6. Okay, the next type of examples that we'll see is ones where you might have to use an identity first when solving. So here my equation is secant squared of x minus 2 times tangent of x minus 4 equals 0. Secant and tangent are not like terms, so I can't combine them. Secant squared of x and tangent, it's not like I could factor this into a single trig expression. So the first thing I'm going to do is I'm going to use an identity that's going to help me get some like terms. I know that there is a Pythagorean identity that is 1 plus tangent squared of x is equal to secant squared of x. So the first thing that I'm going to do is I'm actually going to replace my secant squared of x so that I'm only in terms of tangent. Next, I see some like terms. I have this 1 and -4, so I can combine those. And now I have this tangent squared of x minus 2 times tangent of x minus 3. I have this squared trinomial, so this is kind of like a quadratic trinomial, so I can factor this. I'm going to try to factor this into two binomials. I know a tangent times a tangent is going to give me a tangent squared. I know that a -3 times a +1 will give me a -3 when I multiply, and they will also add to -2 tangents in the middle. So again, I can always check my work by multiplying this back out. Once I have my factors, I'm going to set my factors equal to 0 and solve these equations. My first equation is going to be fairly simple. Tangent of x plus 1 is equal to 0 when tangent of x is equal to -1. And tangent of x equaling -1 happens on my unit circle. This is going to happen when I divide sine divided by cosine, and I get -1. That's going to happen in the second quadrant here at, what did I want, degrees. So at 135 degrees, I have the coordinate point -√2 over 2 and √2 over 2. So when I divide those, I'll get -1. And then tangent is going to be the same if I go across into the other quadrant 180 degrees away, and this will give me 315 degrees, because this one is √2 over 2, comma, -√2 over 2. So those are my two solutions for this equation. X equals 135 and 315. My second equation is going to be slightly trickier to solve. tangent of x minus 3 is equal to 0 when tangent of x equals 3. Unfortunately, 3 is not one of my known tangent values that can be found on the unit circle. So I'm going to have to get a little bit more creative than that. So the first thing that I'm going to do is I'm going to take the inverse of tangent on both sides. Make sure I'm in degree mode. And I'll get 71.6 degrees. So I'm going to really quickly draw that on my unit circle. And then I need to remember about symmetry to find my other angle that would fall on the unit circle. Tangent is always the same when you follow the line into the equivalent lines. So I've got this angle here in quadrant 1, and I need an angle down here in quadrant 3. And because it makes a straight line, I can find this other angle by taking my 71 degree angle and adding 180 degrees to it. So my other angle that will make tangent 3 is 71.6 plus 180 degrees. And that angle measurement is 251.6 degrees. So my full solution set of this problem, starting with my smallest angle and then working my way towards my biggest angle, I have 71.6 degrees, 135 degrees for my first factor, 251.6 degrees, and then my last angle from my other factor is 315 degrees. So there is my full solution set. Okay, for this next example, it says solve in terms of radians, and we're going to use an identity in this problem. So the first thing that I notice is I have -2 cosine of x on one side of my equation is equal to sine of 2x minus cosine of x. Whenever I have a cosine and a sine in the same problem, chances are I'm going to need to solve by factoring. So the first thing that I'm going to do is get 0 on one side. So I'm going to add 2 cosine of x to both sides and combine like terms. Okay, once I have this, sine and cosine are not like terms. I do see the sine of 2x. Sine of 2x is a double angle, and so I'm going to use a double angle identity here. Sine of 2x is equal to 2 sine of x cosine of x. And so I'm going to use that identity to replace, and then that way I can have a little bit more like terms that I can get into solving. Now both of these terms have a cosine of x, so I can factor out a cosine of x and solve by factoring. See if you can pause this video and finish this problem from here on your own. Pause the video and check your work. My first factor, I factored out a cosine of x, and so that was my first factor, set it equal to 0. Cosine is 0 at pi over 2 and 3 pi over 2. My second factor was 2 sine of x plus 1, and when I solved this, I needed when sine of x is equal to -1/2. That is true at 7 pi over 6 and 11 pi over 6, and then I wrote my answers in increasing order. So I had 4 total solutions to this equation. Okay, for my last problem, it says solve in terms of degrees by using an identity. We know that cosine of x plus cosine of 2x equals 0. Really important to understand that these are not like terms and I cannot combine them. I cannot make this cosine of 3x. That is not equivalent. So anytime you have a cosine of x and a cosine of 2x like this, we're going to need to use an identity here. One identity that I can use is a double angle. Cosine of 2x has a couple options for replacing. And I'm going to use the one that only has the cosines with it. And that identity is cosine of 2x is equivalent to 2 cosine squared of x minus 1. So what I can do is I can use a substitution and replace, and then this will give me some kind of quadratic equation that I can solve by factoring. So I've got cosine of x plus 2 cosine squared of x minus 1, again using that identity to replace, is equal to 0. I'm going to rearrange this so that it is in standard form, meaning my highest exponent is first. And then I can try to solve this by factoring. I've now turned it into a quadratic. Pause the video and see if you can finish this problem off, factor, and set your factors equal to 0. Okay, to factor, I knew that 2 times cosine of x times a cosine of x would give me 2 cosine of x squared. A negative 1 times a positive 1 would give me a negative 1, and then I just needed to check my like terms. Negative 1 cosine of x and 2 cosines of x would combine to a positive cosine of x. Once I have my factors, I set them equal to 0 and solve. I needed when cosine of x was equal to 1/2, and that is true at 60 degrees and 120 degrees. And then my other factor, cosine of x plus 1, I needed when cosine of x equaled negative 1, and that happens at 270 degrees. My full solution set is 60 degrees, 120 degrees, and 270 degrees. Okay, that's it for this video. We'll do more practice with this in class tomorrow.